For each problem below, v of t represents the velocity of the particle, and s of t represents the position of the particle. The object is moving along the y-axis. All right, so here's my velocity. Here's my position. You know what? I'm going to change our position too, because you guys are going to run into this too in your student practice. When they give you an initial condition, it doesn't always have to be the starting time. Initial condition just means some original position. So, for instance, I'm going to change this to a 2, and I want you guys to do the same. Change that to a 2. And that causes us to kind of feel uncomfortable with something we're going to see in a minute, but it really isn't that big of a deal. Just try not to let the way it looks psych you out, okay? Here we go. So, part A, find the distance traveled on this interval. Now, yesterday we talked about how you find distance. The way you find distance is you do the integral of your velocity function, but with a absolute value on it. So we're going from 0 to 10. And then for part B, we're going to find the displacement. So to find your displacement, it's the same thing, but without the absolute value on it. Okay? So, get out your calculators, turn them on, and we're going to punch that stuff into our calculator. So, push y equals. The first thing we want to do is we want to put that function into our calculator, clear what's in there, because what we were doing last block was a little bit different. And let's type in the velocity function that they gave us, which is x squared minus 8x plus 14. Has anybody not got it typed in yet? Yeah, clear it. Because the one that was from last class is going to be different. So clear.
Clear.
No, I just like reset.
Oh, if you want to reset it completely, it's second plus 712. So I'll wait while you guys are getting that entered. And by the way, one of our elements of our AP Camp Day, we're going to spend a whole hour just on calculator stuff. So just to get you guys used to it. Now, we're going to do the part A now, the distance. Now, it's the same thing, right? It's just absolute value, correct? So how do you do absolute value? I'll show you. So let's go ahead and push math again in 9 to bring up your integral. Now, at this point, you want to put an absolute value in there. So where's that at? You're going to push math, and then you're going to go over where it says num, and you're going to see where it says abs. There it is. And then you're just going to put your function in there. Okay? So, y1. Close your parentheses on the absolute value, or if you have mine. For those of you guys who have nice ones, it looks like what it should. I'll wait. That's right.
You just switch it to so for the fancy ones, we just plug in the integral and put abs in there.
Yeah, for the distance problems. So, and don't be surprised, guys. A lot of times, integrals and absolute value functions are really they're a big load on the RAM of these calculators, if that's what it's called, and it takes them a long time to figure out the answers. So you'll see it thinking a lot. But I'm getting 80.875. What do you guys think? Okay, so I'll pause there and see if there's just a second. Student practice, you guys. You have a new function, so go for it.
Wait.
I'm not in.
Well,
Imagine. Lost my cards. For part A.
Mr. Bailey, did you use that until 10? Oh, snap.
Should be 0 to 5 actually.
Oh, 0 to 5, yeah.
How long? No, wait, that was different too.
And what did we get for that, Eric?
I got 12.08. I'm sorry.
And guys, when you do your calculus, always round to the thousands place. So we want 3 numbers.
1.083.
Thank you. Because that's how they grade it on your FRQ. I don't know if they would actually be that mean, but that's what they say you should have. So I would just always do it. All right, Maya, what's your setup for part B?
in the integral, and then the absolute value. Wait, sorry, wrong. I put in the integral, and then
That was absolute value.
0 to 5, and then y1.
Oh yeah, y1.
Yeah, y1 dx.
And what'd you get?
I got 11.6.
Now that's different than what other folks were getting.
She's wrong.
Okay, you don't.
Dang, okay.
Who said that?
Nah, it came out wrong.
I don't think he meant anything by that. I think he just slipped. What? My guess is, did you type in the correct equation? Did you type this equation in your calculator?
I didn't type in any equation at all.
So that's why. You were probably using the equation that I had originally. So what's our answer for that one, you guys?
What's 417?
7? Okay, there you go. All right, now I'm about ready to show you guys a few things here that might be a little crazy. I wonder if maybe we should just... No, I think I'm just going to do it. All right, here we go. Go back to your example 2 now. Go back to your example 2. All right, now it says find the coordinate of the particle at t equals 10. So in other words, they want me to find what s of 10 is, right? Now how do we find s of 10? Well, yesterday, here's what we learned. We learned that your final spot is equal to your starting amount. Now, what is my starting amount for this problem?
2.
It's 2.
4, 2.
Plus the integral from 0 to 5.
Now be careful here. My integral is going to be from what to what,
0
though?
to 10.
2 to 10. So here's what I want you guys to get out of this. Ready? This number is your final. Even if it's a smaller number than this one, I don't care. If this number's, if whatever's here, the one you're trying to find, that's your final. Whatever number's here, that's your starting amount. We're going to put it there. Okay? Now, let me tell you why that is. You guys remember the fundamental theorem of calculus, right? Integrate little f, you get big F, right? And if I put AB here, B comes first, and then A. So whatever these numbers are, that's what has to be in there, right? And you get this formula just by taking this piece and adding it over here. So whatever these numbers are here, that's what has to be in here. And since that's what we're putting inside, that's what your limits have to be for this to work. Yeah.
If the top number was lower than the bottom,
You still do it this way.
would we still flip the sign?
No, because our calculator is going to do it for us. But if you got to do it by hand, you would have to, right? So Jennifer asked you a question. That's going to happen on your student practice. On your student practice, you're going to end up with a number here that's smaller than this one. So you're going to end up putting a number up here that's smaller than this one. But that's okay. Don't worry about it. Your calculator is going to deal with it. Okay? Now, if you had to do it by hand, yeah, you'd have to flip it, put a negative out here, and integrate by hand. But they're not going to ask you a question like that on here. Now, for the geometry ones we did yesterday, yeah, that's easy. But they don't usually do a whole lot of those definite integrals you have to do by hand because it just takes too long. Yeah?
When we're doing our FRQ, would we have to show the signs changing? Or?
Nope. Nope. This is what I'm writing up here is all you'd have to show. All right, so now it's going to be displacement, right? So we just said a whole lot of things, so I want to back up. How do you find a position? It's final equals start plus displacement, right? We learned that yesterday. All right, so now we just get to type that into our calculator. So what is S of 2, though, first? It's 4. So we're going to type into our calculator 4 plus this displacement, okay? So let's go ahead and do that. Now you guys have to open up your calculators and you have to type my equation back in there again. So yeah, so because you have yours in there, so let's put mine in there. So y equals, I'm going to clear that, and I'm going to type in my, well, mine hadn't changed actually, I just I didn't need to, but you guys need to. All right, plus 14. And then once you got it typed back in there, go ahead and go back to your home screen. Your home screen. Okay, so we're going to type in exactly what I said. So S of 10, we decided, S of 10 was going to be 4, right? Plus the integral. So now I'm going to bring up the integral. 4 plus the integral. And then you type in your thing, right? So function, comma, x. And what are my limits? 62.667. And you want to go to the third decimal place. Okay? That's correct. Okay. Now, we're looking at the next few questions are talking about highest point and lowest point. What does that mean? Candidates test. So I'm giving you guys a lot of information here, but I can't really find a nice place to break this up so that I'm not overwhelming you, because it's all connected. So I'm about ready to flood you guys' minds here. So follow me with my thinking here for a second, yeah?
I got 14.6.
So something's wrong. So when is the object at its highest point and when is it at its lowest point? So what do we need to do?
The velocity.
I heard good answers and all of them. So the main one I was looking for is what Isaac said at Canada's test. However, somebody said something about velocity and graphing it, and you're right. So, but we'll get to that. So when you're doing the candidates test, what are my candidates? I like how you said that. So it's the endpoints. What are my endpoints in your guys' problem here? 0 and 10, actually. See the lower limit here? They didn't give me the starting point. They gave me some random point in between. But my area I'm looking at is 0 to 10. Now, those are my starting points and ending points. But the other parts are now the correct answer, although I like the way Marco said it better, but the correct answer is this. What are the other numbers? They're called the critical values. And critical values are where your what? Not your y values. Where your derivative values equal 0, right? So, what is S of t? S of t is equal to the starting point, right? Plus the displacement from 2 to whatever you want, right? So if that's my function for s, right? Now this is just a number, it's 4, right? If I want to find the derivative of this, what happens to the 4? Gone. And what happens to this? It's just v of t. So s prime of t is v of t. And we want critical values. That's where does this thing equal 0 or where is it undefined? Now, can we find where this thing equals 0? We could do it by, you could try factoring. It won't work, but you could. You wouldn't know that until you tried, but I deliberately made it that way. What if it doesn't work? How else can you find the answer? Quadratic formula. Good job. But we're not going to do either one of those. We're going to do what we did yesterday. We're going to graph it, and we're going to find where it hits the x-axis, because that's where the derivative equals 0. So, I want you guys to know how to do it by hand, but I want you guys to know how to use the calculators too. So, we're going to learn a new calculator skill right now to find out what are my other 2 critical values. I think you guys are going to have 3 on your student practice, but I have 2. So, here's how you do it. Go ahead and push graph. There you go. You can see it's touching the x-axis in 2 spots, right? All right, so I'm going to go through a process to show you guys how you can find on your calculator where it touches the x-axis. This might be a little overwhelming for you, but that's what we're here for. We're here to learn. So, all right, so the first thing we're going to do is this. Everybody follow along with me. You're going to push second, and you're going to push calc. Second, calc. Now, we're going to choose the option that says 0. So click 0. Ready? Now, it says something funny down here at the bottom. It says left bound. Here's why it says this. We're looking for a place where our line touches the x-axis, right? Right there. But doesn't it touch the x-axis somewhere else also? So you can't just say, find where it touches the x-axis. We need to tell our little computer where to look for it. So what we're going to do is we're going to pick a point to the left and to the right of that root so our calculator knows where to look for it. So what this means when it says left bound is it means take your arrow buttons here and you're going to scroll your cursor until you get that little cursor, the blinking dot, to be somewhere to the left of that first root there. So get your little cursor to be right above, to the left of that first root. You guys there? Sometimes it's hard to find the cursor. It's not even on the screen. Look down here at the bottom left corner. You can see where it's at. It tells you the coordinates of where your cursor's at. All right, so go ahead and push enter. So we're going to say, okay, I want you to start there. And then it says right bound. Where do you want me to stop? So you're going to, once again, scroll your cursor until you get past your root to the right of it. We there? Now push enter. Now it says guess. And I guess it's just a polite calculator. It says it's asking permission. Would you like me to guess now? And we're going to say, yes, please. And here's how you say yes, please. You're going to push enter. And there it is. So it touches the x-axis there, but don't do anything. We can write that down. That's my first critical value, right? Don't lose that value. Don't change your screen, though. 2.586. 2.586. Yeah. All right. You guys ready? If you did lose it, you'll get a chance to correct it again in a minute. But for now, it's okay to write this number down. But that's not really the answer, right? The answer is a lot more complicated than that. We just rounded it. So here's the problem. We're going to use this answer later on to calculate something else. If you use a rounded number to calculate something else, your next one could be way off. Okay? That's what we call propagation error. If you use a rounded number into an equation, some equations will take that error and explode it, and you'll be way off. So you don't want to use a rounded value. That you can keep it as your final answer there in my table, but you don't want to use that number. Okay? So what we're going to do is we're going to have this calculator store that value. Okay? So what I want you guys to do is push enter. Now when you push enter, it goes away. That's okay. And I want you guys to push this button down here that says STO. It takes you back to the home screen. It says answer with an arrow. That means it's taking your answer that we just had there, and it's going to store it under a letter. Here's how you do it. You're going to push alpha, the green button here. And then, do you guys see all the green letters here? A, B, C, D, E, F, G. You could use any letter you want. I'm just going to use A. So push the button that has A above it there. And then push enter. Now your calculator has forever decided, okay, now A equals 2.585. And anytime you want to use that number in a later calculation, instead of typing the number, we're going to type A. Okay? So let's repeat this process. So go back to your graph now. Go back to your graph. Now I'm going to let you guys walk me through the process here to find my next root. Ready? And if you don't know, just say I don't know. It's okay. Nate, I want to find this root right here. What's the first thing I need to push?
Second Calc.
Good.
And then 0.
Okay, I'll take it. But after that, I'm going to let Andy do the next step. So, Andy, we just did second Calc, and then we chose 0. Now what do I do? Well, I'm looking for a little more than that. Technically, you could, I think. But what do we want to do? We want to put our cursor where? To the left of the root that you want. So the root I want right now is right here, right? So I'm going to pick a point slightly to the left of that. And then I'm going to do what Andy said, which is push enter. Okay? Now, Andy, what am I going to do? No. No. Now, look at your bottom. It says right bound. So now what do I need to do, Andy? You need to scroll until your dot is to the right of the root that you want. Now you push enter. And now what do I do? Let me call on somebody for this. Let me ask Ricardo. Ricardo, what's next?
Enter, store, and then see
Oh, you're going too far, but you're good. So just enter. So there we go. 5.414 is my next one. So I'm going to write that down now on my table, but don't lose that screen. 5.414. That looks like a 9. Let me fix that. All right. So there's my two critical values, the places where my derivative equals 0. Okay? Now, I'm going to ask Austin, what do I do now?
press enter.
You push enter. Oh, it's gone. It's not gone. Because Marcus is going to tell me to push what next? Store. And then I'm going to ask, not Jade, how about Isaac? What do I push now, Isaac?
I don't know. I was talking to Jennifer. She's distracting me, so I didn't do it.
I remember you saying plus A, but I don't know where you get that A from.
Good. Okay, so we need the A in there, right? So let's see where that A comes from. Jacob, how do I get the A? You push alpha, and then choose your... Oh, yeah, we do need to do a different letter, right? Don't put A. Don't put A. All right, let's do B. Uh-oh, I screwed up. Alpha,
No, press delete. Press delete. Press delete. There you go. Now do it.
alpha,
Yeah.
B. Enter.
There you go,
And there it is. I'm glad you guys are good. All right, now, guys, I know this is taking a while because we're learning how to use a calculator, but this will be a lot quicker when you get used to it. So all I've done so far is I've found my candidates, my endpoints, and the places where my derivative equals 0, which happens to be where it touches the x-axis, and I've stored those on my calculator. Now we're going to find out what all these things are. Okay? So, here we go. All of them are going to be found the same way. We're going to take whatever number we want, we're going to plug it in, and we're going to have our starting amount plus the integral from 2 to whatever number we're trying to find. Okay? So, for instance, if I want to find s of 0, then I'm going to be plugging 0 in here in 2 spots, just like that. Now look at it. Isn't that weird? The 0's on top. It should be on bottom, but it doesn't matter. Your calculator's going to figure it out. Okay? So here we go. You ready? So we're going to do, what's s of 2? 4. So let's type 4 math integral y1. Did I not? I did not, so I'll start over. 4 plus integral. Thank you for catching that, Angie. Then type in your function. I'll just kind of go to town here because there's nothing really new here, but if you guys need help, I'll wait in a minute. I'll see if I can help you, but nothing new's happening here. So this is what you should have typed, or what I wrote on the board. I'll pause. So here we go. This answer was 10 point... What was it, 10? Oh yeah, negative 10.667. Okay, now we're going to do the next one. And this is where we're going to use alpha instead of that number. Now you could do it, and you might luck out and get the right answer anyway, but using alpha will guarantee that you're getting the exact answer. So Jennifer, yours will be a little off because I had to type it in by hand, but you should be close. All right, so here we go. So now for the next one, we're going to do the same thing. It's just that we're going to type in, instead of 0, what am I going to put in there now? A. 2.586. So now watch this. So I don't have to type the whole thing again. Just push second and enter. It brings up the last thing that you typed. And all you have to do is go in here and change your upper limit to be A. So put your cursor on top of the 0 and push alpha A. Enter. There's your next answer. And we just have to keep doing that over and over again. So this one is 4.4 4.552. So, you guys ready for the next one? Second, enter. Bring it back again. What am I going to type in for my next one? Alpha B, because that 4.55 there, or 5.414, that's my B. So I'm going to push alpha B as my upper limit now. Enter. 0.781. And then the last one, I think we already did 10, didn't we? 62 point what? Okay, so there it is. I've got my candidates test done. So it seemed like a lot, but once you get used to these keystrokes, this whole slide would take you 5 minutes if you're used to your keystrokes. All right, so here we go. Highest point. What's my highest point? Is at what? T equals 10. What's my lowest point? At T equals 0. There you go. All right, so you guys get to practice on your student practice. Remember that on your student practice, though, you are using a different equation. So you're going to have to go back into y equals and change your equation, okay? All right, so go ahead and see if you guys can figure out your answers there to parts C through E. And there's our answers to the last 3.